Hello, in this video, I will be talking about hypothesis tests for two population means when sigma 1 and sigma 2 are unknown. If one or both of the population standard deviations is unknown, we use a two-sample t-test. So keep that in mind. This is a condition that's very important. Sigma 1 and sigma 2 are known, or at least one of these two is unknown. Again, we are testing two population means. The test statistic is still as before, but because we do not know sigma 1 and sigma 2, we will be using S1 and S2. The general format is the same. The test statistic is always the observed minus the expected divided by the standard error. When you will perform this test on the calculator, under test, you will select two sample t-tests. However, there will be something else in there, something that you haven't seen until now, an option to pool the data or not. So this is what you need to do. If the population variances are equal, or you know for a fact that these two are equal, it's stated in the problem that these two are equal, meaning sigma 1 squared is equal to sigma 2 squared. Then we can combine the sample data to get a better estimate of the common standard deviation of the population S. And this is called pooling the data. And then on the calculator, on the two sample t-test, you will answer the question, pool the data, you will say yes, if this happens. But if the two population variances are not equal, then the standard error is the square root of the sum of the population variances, exactly as it is for the two sample z-test. In general, we only pool the data when we have a reason to believe that the population variances are equal. It will be stated in the problem. You will see it in the problem. But keep in mind, if in doubt, it's always better. Do not pool the data. If you're not sure, you don't know, they don't really state that the variances are equal, do not pool the data. That will be the extra thing that you will see on this type of test. Pooling the data changes the degrees of freedom of the test. So for each situation, we have a different formula for the degrees of freedom. For this type of test, make sure you look for the degrees of freedom on the calculator, because the calculator will compute the degrees of freedom for us automatically. So we'll go over this example. A pharmaceutical company is testing the effectiveness of a new drug for lowering cholesterol. As part of this trial, they wish to determine whether there is a difference between the effectiveness for women and for men. Using alpha equals 0.05 level of significance, is there evidence that the drug is more effective for women than for men? Let's write down the given information right here. So in this column, we have information about women. In this column, we have information about men. So let's write down the given information. I'll be using number 1 as a subscript for all the information for women and 2 for men. So the first sample size, women, is 80. Men, sample size is 50. The mean effect for women, X1 bar, is 4.5. And for men, which I will denote, X2 bar is 3.85. The sample variance, again, the variance is given, so you have to pay attention to that. Sigma 1 squared is 3.5. Actually, is the sample variance. The sample variance is given. Again, pay attention, it's the variance, but this time is for the sample, so it will be S1 squared, which is 3.5, and S2 squared is 3.5. Okay? And the question is there evidence that the drug is more effective for women than for men? So is mu1 greater than mu2? So what we will do, we will perform a test comparing mu1 and mu2. let's get started. Step 1, write down the hypothesis. The hypothesis can be written in different ways, so I'll show you again 2 different ways, H sub 0, H sub A. This one, it's strict inequality, so this one will become actually H sub A, meaning the other one, which is H sub 0, is less than or mu1 less than or equal to mu2. Now, you may see this written this way, or if we move mu2 to the other side, you will see it written as a difference, mu1 minus mu2 less than or equal to 0, and accordingly, mu1 minus mu2 greater than 0, okay? So regardless of which form you see the hypothesis written, you should be able to identify that this is testing 2 means. Now, because the question is right here, we will identify this as being the claim, and this is a right tail test. Let's move on to step number 2. Step number 2, we know we are doing a test for 2 means, and we're wondering if we use a T distribution or a Z distribution. We will simply watch the given information. Here is the given information. We see S1, S2, not sigma, and because of that, we know we should be using a T distribution. I will not list the degrees of freedom. The degrees of freedom will be given to me after I do the test. So I will do a 2-sample T test. And I can go ahead and do the test and find the p-value. However, for this problem, let's try to do this using the critical value method. So at this step, I'll simply write down alpha, which is 0.05. I should have put this in here. And I'll try to find the critical values. In order to find the critical values, first I need to know the degrees of freedom. So I will have to run the test, okay? So here I have the calculator 2-sample t-test. This is option 4. I have statistics, so I will input the information. X1 bar is 4.5. Standard deviation. And again, the variance was given. So to get to the standard deviation, I need to square root the variance. Square root of 3.5. N1 is 80. X2 bar is 3.85. Standard deviation of the second sample is square root of 3.5. N2 is 50. I'm doing a right tail test. So I will pick mu1 greater than mu2. And now I have the question, is this pooled, yes or no? In order to answer this question, I'll be looking at the given information, or I'll read the problem again. Do I have any indication that the population standard deviations are equal, or the population variances are equal? This is what this question asks us. Are the population variances equal? In other words, is sigma 1 squared equal to sigma 2 squared? I read the problem again. There is no indication that sigma 1 squared equals sigma 2 squared. I look at this. Even though the sample variances are equal, that's no guarantee that the population variances will be equal. Okay? And because of that, for this extra question, I will leave it no. I will choose no. And now I will scroll down and calculate. And here are the results. So the results right here are the t value, the p value, and the degrees of freedom. So the test statistic is 1.93. I will not copy down the p value because, as I said before, I want to do this problem using the critical values. Okay, so I will not copy this. But I need the degrees of freedom for this distribution because I want to know which curve of the family of curves to pick. This will be 104.15. Okay, so at this point, I know the test value and I will find the critical value. Let's do that, finding the critical values. We start with alpha. We know this is a right-tailed test. We know that this will be the T distribution with the degrees of freedom of 104.15. This is a right tail test. This is the T distribution. Right here we have alpha, which is 0.05. So we are wondering, what is this critical value? In order to find the critical value, TC, we simply do inverse T area to the left, which is 0.95, degrees of freedom 104.15. So this is how we will find that critical value. Let's do so. So I go back to distributions, second bars, inverse T, hit enter. Area, it's 0.95. This is area to the left. Degrees of freedom, I have only an estimation, 104.15, but that should be good enough. And let's see what is the critical value. The critical value is 1.6. So in order to conclude the test, all I need to do is see where the test value or the test statistic should be placed. So I take the test statistic from here and I will place it accordingly. Where does it fall? Well, it falls to the right of this value because that's 1.66. My test value was 1.93, which means it falls in a critical region. Because of that, I will reject the null hypothesis. So the next step, which is step 4, will be to make a decision, and I made a decision based on the critical value region or the traditional method. And let me write it down here. That's step 4. I'll just say reject H sub 0 because the test statistic falls in a critical region. In other words, T is greater than TC, and this is a right tail test. So step 5, I will simply conclude and I will say at alpha equals 0.05, level of significance, there blank, enough evidence to blank the claim that the drug is more effective for women than for men. So coming back here to fill in those blanks, remember we rejected H sub 0, which means we have enough evidence. There is enough evidence to support this claim. And we've done this using the critical region method or the traditional method. Next, we will do another example. This time we have data. An engineer wants to compare tensile strength of steel bars that are produced using a conventional method and those produced with a new experimental method. To do so, she randomly selects steel bars manufactured using each method and records the following tensile strength in newtons per millimeter squared. With experimental method, this is what they got. With a conventional method, this is the result. At alpha equals 0.10, can the engineer conclude that the experimental method produces steel with greater mean tensile strength? Assume the population variances are not equal. So here we have given information, data, raw data. We have alpha, which is 0.10, and we have to answer the question, is the experimental mean tensile strength greater than the conventional one? And this is important. The population variances are not equal. So as a question, we will actually test two means and we'll be able to answer the question. Let's do so. Start with stating the hypothesis, H sub 0, H sub A. Again, we can write the hypothesis using the inequality this way or looking at the difference. I'll just simply use it this way, mu1 greater than mu2. And of course, this one will become, the H sub 0 will become mu1 less than or equal to mu. We're talking about this being the claim. We want to see if the experimental one produces still with greater mean tensile strength. So this will be a right tail test. Step 2, because we don't know sigma, all we have is raw data. We will do a t-test, so we'll be using a t-distribution. We do not know yet the degrees of freedom. We'll have to actually perform the test to come up with the degrees of freedom, but we know which test to do. It's a two-sample t-test. Alpha, it's 0.10. And this time we will do this test using the p-value method. So at step 3, after we perform the test, we will actually write down the results. And the results should be the statistic, t, and the p-value. Let's do the test. So the first thing we do when we have data is enter the data into lists. Click on stats, edit, and enter. I have already entered the data in this list. I have experimental in list 1 and conventional in list 2. Now I go back to stats. I choose tests, and I know I'll be doing a two-sample t-test. So I'll go to option 4 or just click on 4. This is the two-sample t-test. This time data is on list 1 and list 2. So I'll simply move this tab to data, hit enter. Do I have my experimental in list 1? Yes. And my conventional in list 2? Yes. Frequency stays 1. What type of test I am doing? I already said, and it's right here. It's a right tail test. So mu1 greater than mu2. Now I got to the question pooled yes or no, and I read again the information right here. Assume the population variances are not equal. Not equal, that means the answer right here is no. Okay, scroll down, hit calculate, and here I have the results. What I'm interested in though is only this piece, the t and the p-value, and of course we have the degrees of freedom right here if we need the degrees of freedom. But for the fact that I'm doing this using the p-value method, I don't really need the degrees of freedom this time. So my values are 3.43, and the p-value, it's a small one. It's 0.001, rounded to 3 decimal places. Well, you know, let's just make it 1, 2, rounded to 4 decimal places. Okay. If I want, I can sketch a graph, but this is what I got to, and that's enough. I can actually go ahead and conclude this test right away. I'll simply say at step 4 that the p-value and alpha compares this way. The p-value is less than alpha. Alpha was 0.10, which means I will reject H sub 0. Now 5, I will say at alpha equals 0.10 level of significance, there is or is not, but we already know when I reject, I always start with is, enough evidence to blank, support, or reject the claim that the experimental method produces steel with greater mean tensile strength. Coming back here, support or reject? Yes, support, because we rejected H sub 0 and H sub 0 was this one. So we are supporting this claim. And this concludes the video.